Hello, my students. Here we are. It's our last section of Unit 5. So we are going to be kind of working backwards here. We are going to be writing the equations of polynomials. So I'm going to give you some criteria, some characteristics, and then you are going to come up with that polynomial. So if you can kind of guess, this is going to involve a lot of multiplying because most of the time we know the factors, so putting them all together to get the polynomial is working backwards of factoring, which is just multiplying all the factors together. And that's really as easy as it is, multiplying and possibly adding like terms, etc., etc. Just wanted to quickly recap. Remember the fundamental theorem of algebra that we discussed in 5.6. That second part of it is really the most important part, is that every polynomial function of a degree n greater than or equal to 1 has to have that many zeros. So if we have a degree of 5, we have 5 zeros. If there are 7 zeros, then it has a degree of 7. If there's 2 zeros, it's a degree of 2. Those numbers should always be the same. That also includes your multiplicity. So if you have a factor raised to the power of 3, that means it has a multiplicity of 3. Those are 3 of the zeros. So that does count in that count. So also want to remind you, remember, imaginary zeros and irrational zeros always come in pairs. Think about that. How do you get an imaginary number? Well, you get an imaginary number by taking the square root of a negative. Anytime we are solving and we take the square root of something, we have to include the positive and the negative. That's also where the irrational zeros come into play. So just remember that. And then, of course, I put those two theorems, the irrational root theorem. If a polynomial has rational coefficients and a plus b radical c is a root of the equation, meaning that is where it's a 0. If I plugged it in, I get 0. It says where a and b are rational and the square root of c is irrational, then a minus b radical c is also a root. And so that's what we just talked about. If I have 5 radical 7 as a root, then negative 5 radical 7 is a root. If I have 1 plus radical 3, then 1 minus radical 3 is also a root. They come in pairs. Same thing with your complex numbers. Remember, they're complex conjugates. If a plus bi is an imaginary root of the polynomial, then a minus bi is also a root for the same reason. So that hopefully doesn't confuse you too much, but we just need to make sure that we remember that whenever we're given a list of zeros, because I'm not always going to say, well, negative 2i and positive 2i are roots. I might just say 2i is a root, and then that you'd have to know that, well, negative 2i would also be a root. So let's get started. It says, write a polynomial of least degree with a leading coefficient of 1 that has the given zeros. So I am literally giving you the factors. I'm giving you the roots. I'm giving you the zeros. So if I have a 0 of 3 with a multiplicity of 2, how do we write that as a factor? Well, that means it's x minus 3 with a multiplicity of 2. I also have the square root of 7 as a factor. Well, that is an irrational number, meaning I have x minus root 7 and x plus root 7. Okay. Another way you can think about that is, how would you get x to be plus or minus root 7? Well, that means x squared minus 7 would have had to have equaled 0. Moving that negative 7 over, taking the square root plus or minus root 7. Boom, done. So if you know how you got the root, then you should be able to come up with the factor pretty easily, instead of having to write both the factors down of x minus radical 7 and x plus radical 7, because if we just write that down, we are going to have to go back and multiply. FOIL. Then you have this, then you'd have that, then you'd have plus 7, because radical 7 times radical 7. So it saves you a little bit of steps. Notice these cancel out, and so I'm just left with, that would be a minus, my bad, because it's a minus times a negative. Minus times a positive. So you get the same thing. So just keep that in mind. You should be well aware of how you got plus or minus radical 7 as a root. So hopefully you know what the factor looks like. Okay, so here it is, but then it says I have to write it as a polynomial. So right now it's just in factored form. So what I'll need to do is FOIL out that first one. So x minus 3 times x minus 3 is going to give me x squared minus 6x plus 9. And then I still have my x squared minus 7. And then I need to multiply those together. So I'm going to go ahead and distribute the trinomial to the binomial. So x squared times x squared times negative 7. Negative 6x times x squared, negative 6x times negative 7, and then 9 times x squared, and 9 times negative 7. And so I've multiplied my two factors together. So now all I need to do is combine my like terms and write it in standard form. X to the fourth minus 6x cubed plus 2x squared plus 42x minus 63. So that is a polynomial with a leading coefficient of 1 in standard form, and it has a degree of 4. So let's check. If it has a degree of 4, that means it should have 2 zeros. Well, I had a 0 at 3 with a multiplicity of 2, so that's 2 zeros at 3. I also had a 0 of square root of 7, which means I also have a 0 at negative square root of 7. And if you need to write that in your list, so be it, if that's going to help you remember. Okay, so I see a total of 4 zeros, and I have a degree of 4. That's exactly what I wanted. Okay, let's try it again. The next one I have, let's go, what's the right color? 2, I have a 0 of 2, so that would look like x minus 2. And I have zeros of 3i, which means I also have a 0 of negative 3i. So again, I'm hoping that you understand how to get that those zeros of plus or minus 3i. But if you don't, you're more than welcome to put x plus 3i and x minus 3i. You would have to FOIL it, so you're going to end up with what you should have started with if you know you're factoring and multiplying out pretty easily. But you can start with this. That's totally fine. I would go ahead and FOIL these together and then distribute the x minus 2. So FOIL x times x, a negative 3ix, a positive 3ix. Those are going to cancel out. And then a negative 3i squared. Okay, well, let's think about what we do here. I'm squaring 3. I'm keeping that negative here. I'm squaring the 3, and then I'm squaring I squared. But what is I squared? Negative 1. So this is really negative of negative 9, which is just positive 9. So really we just have x squared plus 9, which I'm hoping you knew that, because if it would have been x squared minus 9, that's the difference of squares. If it would have been x squared minus 9, that would have been x plus 3 and x minus 3. But because it was x squared plus 9, if that was our factor and we set that equal to 0, then we get x squared equals negative 9. Take the square root, negative underneath the radical, so that's imaginary. The square root of 9 is 3, so that's plus or minus 3i. Okay, so you should already know that. If not, you probably will get into the hang of it. So I'm going to go ahead and say that this goes into x squared plus 9. That is still being multiplied to my x minus 2. So when I multiply those two things together, I can actually FOIL this one because it's two binomials. X times x squared, x cubed, x times positive 9, negative 2 times x squared, and then the negative 2 times 9. And then all I want to do is rewrite it so that it's in standard form. Still have a leading coefficient of 1. It's in standard form. There's my polynomial. That's going to give me zeros of 2, positive 3i, and negative 3i. Degree of 3, 3 zeros. 2 of them are imaginary, 1 of them is real. Going back to A, 2 of them are irrational, 2 of them are rational. They're all real. All 4 of them are real. It's just that 2 are irrational and then the other 2 are rational. Okay, so let's try it again. 5, and 2 minus radical 3. Well, if 2 minus radical 3 is a root, then that means 2 plus radical 3 is also a root. So here we go. X minus 2 minus radical 3 and x minus 2 plus radical 3. All right, I'm going to go ahead and put these together. And actually, I'll show you something. And so we don't have to multiply a 2 minus root 3 times x and a 2 plus 3 times x and a 2 minus root 3 times 2 plus root 3. It gets a little confusing. So let me show you a shortcut here. Still working with these two. Let me go do that still. Your answer, whatever your factor is, when you set it equal to 0, you got an answer of 2 plus or minus root 3. Hopefully you can agree with that because of these zeros right here. That's my zeros right here. So I came from here to here by doing some math. Why can't we just work backwards with that math? We can. Okay. So if I want to undo this quote unquote, I want to set it equal to 0. I want to make this something equals 0. Well, what I can do first is I can subtract the 2. How do I undo the square root? Square both sides. How do I move that 3 over? I would subtract the 3. Okay. What I would need to do here, though, because I'm not done, is I would actually need to FOIL out that x minus 2 squared. So that's going to be x squared minus 4x plus 4. And then I still have my minus 3. So, excuse me, that's really going to be x squared minus 4x plus 1. Okay, so that means that's what I started off with to get the zeros of 2 plus or minus root 3. I know you're thinking, oh my God, that's a lot of work, but it's actually so much easier and so much quicker than trying to FOIL out these two factors together, because I guarantee first times first is easy. But when you go to do that outer and you have a negative 2 plus root 3 times x and then a positive, and then you have to do the 2 minus root 3 times the 2 plus root 3, it can just get a little messy, okay? I know I write very big, but what you're doing is setting your x equal to what your roots are, 2 plus and 2 minus root 3. Then I want to set that equal to 0. I want to figure out what the factor was or what I started with. So it's exactly what I did. I just worked backwards. I FOILed out that thing that was squared. And so I know that that x squared minus 4x plus 1 is going to get multiplied to this guy over here. We cannot forget about this guy, okay? So let me make this a little bit smaller. So I can kind of do that. And so then I have x minus 5 times x squared minus 4x plus 1. And so then I just multiply that together. So I'm going to distribute the x and the negative 5 to everybody. So that's x cubed minus 4x squared plus x minus 5x squared plus 20x minus 5. Just want to rewrite it in standard form. X cubed minus 9x squared plus 21x minus 5. Here's my polynomial, a leading coefficient of 1, degree of 3, and I see that I also have 3 zeros. 5, 2 minus root 3, 2 plus root 3. All of them are real. 2 of them are irrational, and the other is rational. Okay, let's try one more time. Over here in D, I have zeros of 1, negative 2, and 3 plus I. Well, that also means that I have 3 minus I as well. So this is a total of 4 zeros, which means at the end, we should be getting a polynomial with a degree of 4. So I have x minus 1, x plus 2, and then I have, again, that x minus 3 plus I and x, minus 3 minus I. Going to FOIL these, again, is going to be a headache. So use the shortcut. If I know that my factor gave me zeros of 3 plus or minus I, work backwards. Subtract the 3. Remember, I is the square root of negative 1. Let's rewrite that. How do I get rid of that? Square both sides. Okay, if you need to FOIL out the the left-hand side before you add that 1 over, you can, or you can add the 1 over and then FOIL it out. X squared minus 6x plus 9 plus 1. X squared minus 6x plus 10. So this is what it's going to get multiplied to. I got to FOIL this part out. X squared plus 2x minus 2. So that's just x squared plus x minus 2. So now I need to multiply those two trinomials together. So I'm going to make this a little bit smaller. I told you it was a lot of multiplying. Okay. Let me erase that. Okay, so now I have my x squared plus x minus 2 times x squared minus 6x plus 10. And I need to multiply those two things together so I can get my entire polynomial with a degree of 4 and a leading coefficient of 1. Okay, so I'm going to distribute everything in the first trinomial to the second trinomial. X squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. X squared times 10 is 10x squared. X times x squared is x cubed. X times negative 6x is negative 6x squared. X times 10 is 10x. Negative 2, I'm going to run out of room. Hold on, let me slide this over. Oh, no. Dang it. Okay, let me try it again. Sorry, guys. Okay. That should be good. Okay, so did the x term right now, the negative 2. So negative 2x squared plus 12x minus 20. And now we just combine like terms and write it in standard form. So this is going to give me x to the 4th. That's this guy. Then I'm looking for my cubes. I see a negative 6x cubed and a positive x cubed. So that's going to be a negative 5x cubed. So boom, boom. Then I'm looking for the squares. So I see a positive 10x squared and a negative 6x squared and a negative 2x squared. So that's going to be 10 minus 6 minus 2, which is just positive 2x squared. Bye-bye, bye-bye, bye-bye. And then x is 10x and 12x. Boom, boom. And then your minus 20. Leading coefficient is positive 1. Degree of 4. 4 zeros. 2 of them imaginary, 2 of them real. Okay, this is not hard, guys. When I give you the 0, you write it as a factor. The only thing that's different now is remembering if I give you an imaginary or an irrational, you have to write the other one, the conjugate of it, okay? If I give you something that's positive, write the negative. If I give you the negative, give me the positive. All right, a lot of multiplication. All right, let's try one more time. It says find a polynomial. This one's going to be a little bit different just because our a value doesn't have to be 1 here. So it says find a polynomial of a degree of 4 with zeros of 0, negative 1, that should be a comma, not negative 1.2, but 0, negative 1, 2, and negative 3. And then it also gives us this thing about saying f of 3 is also 288. So what does that mean? That means when x is 3, our y value is 288. Okay, we're going to use that a little bit later on. First thing I want to do is write out what this polynomial looks like in intercept form. 0 of 0, a 0 of negative 1, a 0 of 2, and a 0 of negative 3. So here's our polynomial. And yes, I can multiply it out and write it in standard form, but it doesn't say in the direction, so I can just leave it as is. But I need to worry about this when f of 3 is equal to 288 business. Well, the way that we are interpreting that is when x is 3, the y value is 288. That means if I plug in 3 everywhere I see an x and set my polynomial equal to 288, I need to solve for the a value. There could be some a value right here. So even if I start this with a 5x or negative 2x or whatever, that's still a 0 of 0. This a value doesn't change these 4 zeros at all, okay? So that's what we're going to do. So I'm going to say 288 equals something times 3 times 3 plus 1 times 3 minus 2 times 3 plus 3. Okay, so that's 288 equals a times. That's 3 times 4 times 1 times 6. 3 times 4 is 12. Times 1 is 12. Times 6 is 72. So that means 288 equals 72a, which means a is going to equal 288 divided by 72, 4. Okay, so a is 4. So that means my polynomial, f of x, g of x, p of x, whatever, is 4x times x plus 1 times x minus 2 times x plus 3. If you want to multiply all that out, be my guest. Directions don't say we have to. This is a polynomial. It's just in intercept form, not in standard form. Totally fine. Okay, this is where the lesson ends. Okay, because this lesson is all about writing polynomials, though, we put in examples 3, 4, and 5, but 3, 4, and 5 are really what you focused on in 5.1, which was the cubic parent function and how to transform it. So I'm going to go over them again. It's not going to take long, but just remember, just know that this is kind of where the newness, quote unquote, ends. The rest should just be a review. So let's go pink. It says the cubic parent function is horizontally compressed by a factor of 3/4 and reflected over the x-axis, followed by a shift up 7. Write your new function. Well, if I know that I'm horizontally compressing, that means inside my parentheses, I need to see a number bigger than 1. This number is not bigger than 1. The reason being, remember, is we divide by the number we see, which means we're multiplying by the reciprocal. I'm multiplied by 3/4. That's the reciprocal. That means I need to see 4/3 inside the parentheses. Okay, when I see this, I should say that is horizontally compressing by a factor of 3/4, which is exactly what the problem says. I also reflect over the x-axis. That is a vertical flip, negative in front. Hasn't affected anything. Followed by a shift up 7. That is the correct order, positive 7. If this and this were to have been flipped in the problem, going up 7 and then flipping, if I go up 7 and then flip, I'm now down 7. This negative wouldn't have been distributed here, but it was in the correct order. I reflected and then I went up 7. So this is exactly what I need to see. This is my new function. Okay, let's try it again. Oh, no, not that one. The function f of x equals x minus 1 cubed plus 3 is shifted right 3, down 4, followed by a vertical stretch by a factor of 5 to create this new g of x function. Write the new function. Well, we're not starting with just the parent function. We're starting with something that has already gone right 1, up 3. Well, if I've already gone right 1 and I want to go right 3 more, then that means in total I've gone right 4. This means I've gone up 3 already, but then I want to go down 4. Well, if I've gone up 3, now I'm going down 4, then that means I end up going down 1. So this is this part right here. And then it says followed by a vertical stretch by a factor of 5. That means everything here is being stretched by 5, which means I do need to write this new function as 5 times x minus 4 cubed minus 5. That 5 gets distributed. When I distribute the 5 to this first part, I'm not saying that's 5x minus 20. I'm just distributing to multiply them. Okay, it's still a vertical stretch. But I do have to apply that vertical stretch to my shift down 1. Okay? And the last one. This one kind of takes a little while, so just be patient. So it says the function f of x cubed plus x squared plus 3, is shifted right 3 down 4, and then followed by a reflection over the y-axis to create this new function g of x. So what I like to do is I like to kind of break up these transformations. I know going right and down, you can do that at the same time and it doesn't affect one or the other. The word followed by the reflection of the y-axis will then kind of applies to everything we just did. So what I'm going to do is I'm going to do these two transformations first, and then I will follow by the reflection of the y-axis to create my new function. If I shift right 3 and down 4, then that means everywhere I see an x, I'm going to replace it with an x minus 3 because that's going right 3. But I also go down 4. That down 4, remember, is written on the outside of any parentheses, so it just gets tacked on at the end. So what I'm going to do here is I'm going to expand and combine like terms. So this is now going to be x minus 3 times x minus 3 squared, which I know is x squared minus 6x plus 9. I'll just write this. Okay, so this is another x squared minus 6x plus 9. And then this will just be minus 1. Then I have to multiply these together. So this is going to be x cubed minus 6x squared plus 9x minus 3x squared plus 18x minus 27. And then plus my x squared minus 6x plus 9 minus 1. So combining all these terms together, I have x cubed. Then I have a minus 6x squared, a minus 3x squared, a positive x squared. So that's negative 8x squared. And then I have 9x, 18x, and negative 6x. So that's 9 minus 6 is 3. 18 plus 3 is 21. And then I have my negative 27, my positive 9, and my negative 1. So that's going to be a negative 19. So this is my function after doing these two transformations. But then it says you follow by a reflection over the y-axis. Well, how do we write a reflection of the y-axis? That's a horizontal flip. Anything that's horizontal goes inside the parentheses, which means that's where my x is. So if I replace every x with a negative x on the inside, that is my reflection over the y-axis. So now I just simplify that. A negative x cubed is still a negative x cubed. This is going to be a negative 8 times a positive x squared. This is going to be a negative 21x, and then that's still a negative 19. So it didn't change a whole bunch, but it did change some. And this is my final g of x function. So I know that one, like I said, it took a little while, and it was in standard form, not vertex form, so that was a little bit new. But remember, these 3, 4, and 5 are all from 5.1. Okay? So examples 1 and 2 are really just the lesson for 5.7, writing equations of polynomials. Bye.